Good morning, all. Myself, Dr. Balaji Maram, working as a professor, SR University, Warangal, Telangana, India. Today, we will discuss about some of the concepts related to the signal handling. Which earlier in previous class we have discussed about the signals. So when a process under execution because of some internal factors or external factors, some set of signals will be generated. After generation, the kernel tries to deliver the signal to the concerned process, but when the process is in a position to catch it, it can catch it. Otherwise, the kernel should wait until it delivers the signal to the target process. Okay? So, after generation of a signal, the corresponding signal action will be taken. The signal actions means like sometimes it is like the default action. Sometimes means the action will be taken care by the user process, and sometimes the action will be ignored. Okay? So this is about the signal. Here, signal handling in Linux. Means signals handling refers to the mechanism by which a process responds to a signal delivery by the kernel. Already we have discussed about all these things. Now, signal handling enables process to gracefully terminate, handle asynchronous events, synchronize with child process, recover from faults. So here, how to handle the signal? So here we can handle the signal properly or handle asynchronous events. Okay. Next, synchronize with the child process. Sometimes already we have discussed about the parent and child process. So when the parent is not able to handle the child, automatically the child process will be converted as a zombie process. When zombie process are existing, it disturb the entire the process table. So that is the reason it is better to avoid the creation of a zombie process. So how to create, how to handle means how to avoid the creation of a zombie process. So with the help of wait and wait PID system calls. So with the help of wait and wait PID system calls, easily we can handle the termination of a child process. Automatically it eliminates the creation of a zombie process. The next one, recover from faults. Okay. Sick child. What is SHCHLD is a signal sent to parent process when child process is terminates and the child process stops and the child process resumes. Okay, it mainly used to avoid zombie process creation, perform cleanup using wait and wait PID system call. This is the example. Uh, Example include stdio.h, hash include stdlib.h, hash include unistd.h, hash include signal.h, hash include sys/wait.h. So here this is our own handler void sigchld underscore handle. Here one and only argument int sig and int status paid underscore tpid and read the terminated child, that is PID is equal to wait of ampersand status. Now the child process percentage D is terminated. That specific message will be printed by the user defined handler. Int main function signals sig chld comma sig chld underscore handler means already we have discussed when the signal function receives sig chld system call, automatically the corresponding user defined function will be executed. Next, PID is equal to fork. So automatically it creates one child process. and after fork the code will be same in parent and child process. So when it is a child process, then PID value is 0, so automatically the true part will be executed. If PID is equal to 0, then child process printf child process is running, then it prints that message continuously. But here we have taken sleep of 3, automatically it waits for 3 seconds, then it prints the same message and so on. Then it prints child exiting, then exit of 0. So that code will be executed by the child process only, and the same code is available in parent process also, but the else part will be executed in parent process. And the in parent process the loop is while one means always true, that is like that will become like infinite loop. Then printf parent is working, then sleep 1. Okay, so it waits for 1 second, then again printf, 1 second printf, and so on. So automatically this code will be executed by the parent and child process. Then child runs for 3 seconds, child exits, parent receives the signal, that is SIG then handler executes wait to clean up the child. So automatically the parent process executes wait function, and wait function waits for termination of a child process. So in this scenario the child process will not become like zombie process. So automatically this specific practice eliminates the creation of a zombie process. Zombie process is avoided. Now, next system call signal mask and Sig PROC mask. Okay, yeah. What about this function? A signal mask defines which signals are blocked from being delivered to a processor. Blocking does not discard the signal; it defers delivery until unblocked. So here already we have discussed, when it creates a signal, the signal will be delivered to the specific process only. But when the process is not in a position to catch that signal, then the kernel should wait until delivers the signal to the target process. So that is like blocked and unblocked. Okay, now what about this system call SIG mask system call? What about the general form? Here the return type is integer. SIG mask int how star set star old set. Now what about first one? SH underscore block. It blocks the signal. This is first argument. First argument into how. How means different options are there. Sig block blocks the signal. Sig unblock unblocks the signal. Sig set mask replace signal mask. Replace signal mask. What about example? Hash include stdio.h, hash include signal.h, hash include uni.h. Next main function set that is the variable name is block underscore set. Sig empty set the first argument is ampersand block underscore set. Next that is like initially it is like empty. Next we need to add some set of signals, that is like SIG add set, okay, ampersand block underscore set comma SIG int. Okay, next automatically it will add that signal. Next one SIG PROC mask, okay, sig underscore block. So here we are trying to block that signal. That is first argument. Second one is ampersand block underscore set. Third last one is null. So here SIG int is blocked for 5 seconds. Okay, here this process don't want to take the signal for the coming 5 seconds. SIG int. After SHINT means generation and expiry of 5 seconds, then the function is SIG mask. First argument is SIG underscore unblock. Now it is unblocked. Now the kernel delivers that signal to the specific means process. Okay, so that is the meaning of sh underscore block, sh underscore unblock. Unblock means the kernel can deliver the signal successfully to the target process. Now printf shint is unblocked. Next, while one sleep one. Okay, that is like an infinite loop. First of all, we need to create an infinite loop. When it is infinite loop, usually we are pressing control plus C. So when it is control plus C, the kernel generates one signal SAGINT. But here SAGINT will not be delivered to this process because it is in blocked state. After 5 seconds, that block will be removed. Now it is unblocked. Unblocked means that is ready to take that signal SHINT. So here pressing control plus shift during the blocked period has no immediate effect, but after 5 seconds that will be delivered to the target process successfully. Now here default signals. Earlier also we have discussed about signals. When there is a signal, the signal based on the signal, the default action will be executed. Otherwise, the action which was defined by the user will be executed. Otherwise, the signal will be ignored by the kernel. So these three things will be happened when signal is generated. So here in Linux system signal handling, two important predefined signal dispositions are available. First one is SIG underscore DFL, default signal handling. Default signal handling. The second one is SIG underscore IGN, ignore the signal. They are used with the signal or SIG action system calls to connect how a process responds to a signal. Okay. Now here we will discuss about SIG underscore DFL. DFL means nothing but default action. Means for every signal there is a default action that is user wish. Otherwise, user wants to create their own action, they can create. Otherwise, the default action will be executed. Here, SIG underscore DFL tells the kernel to perform default action associated with a signal. Already you have observed in previous slides, when there is a signal, what is the default action? In many cases, default action is terminate. Okay, so that is a predefined and that information is available with the kernel. Now here each signal has a predefined default behavior such as usually terminate the process, terminate plus core dump, stop the process, continue the process, ignore the signal, ignore the signal. So these are the different default behaviors when the kernel generates one signal. Just once again, default actions. SIGINT, the default action means suppose when the user press Ctrl plus C, automatically SIGINT will be generated. What about default action? Default action is terminated only. Next one, terminate, SAGTERM. So when the process terminates another process, so automatically SAGTERM will be generated and the default action is terminate. Next, SAGSEGV. Okay, it is terminate plus core dump. Okay. Next, stop. When the process wants to stop another process, automatically SAG stop will be generated and the default action is stop only. the target process will be stopped. Next, SAGCONT, that is like continue. So automatically when the process wants to continue the stopped process. So in such scenario, the stopped process will be activated once again. That is like continue. CHLD, SAGCHLD, when the child is under execution and when it gets the termination, so automatically the default it ignores, means the default action is ignore. Okay, so automatically the child process will be terminated. That's it. What is there? Next, uh, the example on SAGDFL. So here the point is uh, when a signal is generated, how the default action will be executed. So here header files are hash include stdio.h, hash include signal.h, hash include unit int main begin. Here uh, we need to execute the system called signal. What to catch? It is trying to catch the signal SAGINT, comma. What is the action? Here action is default. SAG underscore DFL, default. So the default action will be executed here because we have not given any user defined handler. So that is the reason the default action will be executed. Now for SHINT we need to create one infinite loop. While one begin, press Ctrl plus C to terminate and sleep 2. So automatically this message will be visible after every 2 seconds, but that is like infinite loop. But when it is infinite loop, when we want to exit from the infinite loop, automatically we need to press Ctrl plus C. Then the kernel generates a signal, SAGINT signal, but this specific process is ready to catch that signal. Then when it catches the signal SAGINT and the corresponding handler will be executed. Here the corresponding handler is SAG underscore DFL. So that is default action will be initiated. Okay, that is already predefined by the kernel. Then 0. What about execution? When you press Ctrl plus C, the program terminates normally. Okay, there is no any specific special message, special action, because it is a default action. Default. Without SAG underscore DFL, means that is with default action. Now when there is no default action, so here hash include stdio.h, hash include signal.h, hash include uni stdio.h. Here in the place of default action we have defined our own handler. So void handle underscore SAGINT int SAG begin printf SAGINT received. Okay, so when we press Ctrl plus C, automatically the signal will be generated, and this specific process receives the signal. When it receives the signal, the handle which is defined by the user will be executed. Int main begin signal of SAGINT comma handle underscore SAGINT. So here while one because signal interrupt. So first of all we need to create one what is that infinite loop. While one begin printf running, it is running, press Ctrl plus C and sleep 2. So automatically the same message will be visible for every 2 seconds. So when we want to exit from infinite loop, automatically we need to press Ctrl plus C, then it generates a signal. That signal will be handled by this specific process, and what is the action? the action is our user defined function only. Here user defined function name is handle underscore SAGINT. So automatically the statements which are inside handle underscore SAGINT will be executed. Here only printf statement, that is it prints some message like SAGINT received. Okay. Now, second one is SIGIGN. SIGIGN. It tells the kernel to ignore the specified signal. When the signal is ignored, it is discarded. The process continues execution. No handler will be executed. It is a regular process. In specific cases, the signals will be generated. The signal will be handled by the kernel, and the kernel checks the signal should be passed through which process. But when the process receives the signal, it checks whether the default action will be executed, or any specific action will be executed, or the signal will be ignored. Here we are discussing about ignore. So the corresponding constant name is sh underscore ign. Okay. This is a simple example how to ignore the signal. Here hash include stdio.h, hash include signal.h, hash include unistd.h, int main begin signal. Here we need to write signal or sig action. Means in every example we are using signal only. Signal of SAGINT, comma SAJ underscore IGN. IGN means it simply ignores that signal. Okay. Now SAGINT means we need to create one infinite loop while one begin. Printf, a simple printf message is there. Control plus C will not terminate this program. So that is a very important point. When you press Control plus C for exit, it will not be exited because the process ignores that specific signal. Okay. So that is printf. Next sleep 2. So after every 2 seconds, it simply prints one message. Control plus C will not terminate this program. So that is like infinite loop. Means here there is no need of SHINT signal, because after generation of the signal also there is no proper action to handle SHINT, because we are trying to ignore the signal. Ignore the signal means what what specific action will be taken. There is no specific action, because when it generates SHINT, we are ignoring that signal. When we are ignoring the signal means there is no specific output. Okay, so that is the meaning of SIG underscore IGN. Next concept, SIGKILL, SIG stop. So here some signals can't be ignored. Okay, we have option, we can ignore some set of signals, but some set of signals can't be ignored. First one is SIGKILL, SIG stop. Trying to ignore them will have no effect. Okay, when you are trying to ignore the signal, but there is no specific useful output. Okay, first of all, not allowed. For example, signal of SIGKILL, comma SIG underscore IGN, not allowed. Signal of SIG stop, comma SIG underscore IGN, not allowed. Okay, so these two signals can't be ignored by the by the process. Okay, any process should admit those two signals. Those can't be ignored by any process. First of all, SAGILL, illegal action means usually we are executing different types of statements in a program. What about SAGILL? Illegal action, illegal instruction generated when CPU executes invalid instruction. The default action is core dump. Suppose there is a simple example, hash include stdio.h, main function is there. Here main function, one user defined function also there, void within bracket star func and bracket is equal to void star bracket and we have given some address, okay, 0x12345. Okay, now here func, now we are trying to call the function, means function means address is there, function call is there, return 0. It causes illegal instruction signal. Okay, so here we are trying to define a function with the help of some memory address, some address, but when we call the function, this function means finds the function definition is not valid. So directly or indirectly it is like a invalid function call. So automatically it is like a illegal instruction signal. So what about default action? The default action is core dump. Okay. Next one, pipe. So here, what is a pipe? It is our regular pipe what we are using for water flow. Okay, suppose we are doing gardening. Usually we are using some water pipe. So when there is a pipe, the pipe has two ends. From one end, water is means entering, and in another side the water is coming out. Okay, in and out. So here what about signal number, that is 13. What about default action? Terminate the process. Okay, now when it is generated, a process writes to a pipe or socket. So here pipe also, it is one type of inter process communication, only inter process communication. Okay, means when one process writes something, the same content will be reading by another process. Okay, that is like process to process communication. It is very helpful, but here both ends should open for inter process communication. Okay, both ends should open. Okay, but here one end acts as a read and another end acts as a write end, read and write end. So here when it generated, when a process writes to a pipe or socket, the reading end has been closed and there is no process to receive the data. If not handled, the process terminated immediately. Suppose when there is a pipe, read end is open but write end is closed. So automatically it is nothing but some error is in the pipe. Okay, because when one end is closed, then what is the use of the pipe? The water will not flow, no. So that is the reason. So when there is a pipe, both ends should open, one end for reading, one end for writing, one end for writing, another end for reading. So this is about a pipe. This is the example. So here hash include stdio.h, hash include uni std.h, hash include stdlib.h into main. But here two, already I told you two ends should be there. One is read end, second one is write end. So here two ends means here one array, that array maximum size is 2. Here we have taken fd of 2 means fd of 0 and fd of 1. Here then pipe of fd, then it creates a pipe with fd of 0 is one end, fd of 1 is another end. Now close the read end, close fd of 0, printf writing to pipe. Now we can write something to the pipe. write FDF1 comma hello comma pipe. So automatically it writes something to the pipe using right hand. Printf, the line will not be executed, then return 0. Okay, here writing to the pipe, it is trying to write something, but it is broken pipe because the read end is closed. Read end is closed. So automatically the process terminates automatically due to Sigpipe. Sigpipe means that is a damaged pipe, indirectly damaged pipe. Okay, this is about a pipe. Then another example means a close read end attempting to write pipe. So same example only. Here attempting to write Sigpipe received, no reader is available, write failed, broken pipe, program continuous safely. Okay, thank you.